Hi. So in this video, I just wanted to show you pretty quickly how to do a dependent samples t-test, also called a paired samples t-test. So in SPSS, the data set I have here is the data set we went over in class. It's the rats and stimulating their lateral hypothalamus or their neutral area and measuring how many food pellets they eat within a 30-minute period. So I'm going to show you how to do this. It's a paired samples t-test because we're comparing the same rat 1 here versus here, rat 2 here versus here. The point is to ask this question, how much of a difference is there between the two areas? Is there more than a zero difference between the two areas? So I'm going to click on Analyze and then go to Compare Means and then click on Paired Samples t-test. Again, I like the name Dependent Samples t-test, but this is what SPSS calls it. Click on it, and I'm going to show you. As a reminder, if you see here that the variable label is given here, so you can't really see which variable is which. If you ever want to switch, you can right-click and then put display variable names, and so you can see that here. So I'm going to take lateral hypothalamus and I'm going to move it over, and then I'm going to be comparing it to the neutral area. And so you don't have to worry about this second pair. If I wanted to do another comparison, I could, but for this purpose, for the class, we're only going to do one pair. So I'm going to click OK. And we have our results. So we could see here up top, these are the sample statistics. So we could see that the mean amount eaten during stimulation of lateral hypothalamus was 17.7, and the mean amount of food eaten during stimulation of the neutral area was 12.4. So it gives a standard deviation, and it also gives the sample size. We have 10 rats. We don't need to know too much about this, but we could see there's a correlation between how much they eat when their lateral hypothalamus is stimulated and how much they eat when their neutral area is stimulated. So generally there's a correlation, pretty strong correlation. Some rats are hungrier than others. But that's not what we're interested in. This is the correlation, but we're interested in the difference between them. So here is our paired samples t-test. So we have a mean difference. The mean difference is 5.3. That is 17.7 minus 12.4. And that, again, comes out to 5.3. The standard deviation is 3.3. That's the standard deviation of the difference score. But really what we're interested in is this number over here, the p-value. This p-value is less than 0.05. It's 0.001. What that indicates is that our null hypothesis can be rejected. Our null hypothesis that it doesn't matter where you stimulate, the amount that they're going to eat is the same. It's the same for the hypothalamus and the same for the neutral area. So we can reject that null hypothesis and say, no, it does matter. The amount that they eat is when their lateral hypothalamus is stimulated is greater than the amount eaten during the stimulation of the neutral area. And so you would be reporting this p-value and saying our finding is significant. We can reject the null, and also we could say that we could be making a type 1 error. This could happen just by chance 0.1% of the time. So hopefully that was helpful, and hopefully you're going to be catching on. Okay, I'm going to end it there.